What is a subquery and what is a common table expression? Why do we need them and how can we use them? What are the similarities and differences between these two constructs? Let's find out together in this video. Hello and welcome. My name is Elhelw. Today I'm going to talk about a topic that has been requested by multiple people, and that is about a couple of SQL constructs that are sometimes confused, sometimes people don't know how to use them properly. Those are mainly subqueries and common table expressions, also known as CTEs. So today I will show the syntax, and also we will talk about where each of them is better used. As usual, let's start with some examples and then we can go from there. I will focus on subqueries first and then we will talk about CTEs later on. All right, so to start, let's suppose that we have these two tables. I have a customers table, which contains this data. So we have 4 different customers. Each customer has an ID and a name. And we also have the orders table, which contains a bunch of orders. Each order has an order number, the customer ID, and the amount of that order. All right, let's keep this data here on the side so that we can refer to it as we see the query examples that we're going to work with. All right, so for the first query, I want to get the total amount for each customer, right? So we want to basically sum up all the orders for each particular customer and get that total amount for the customer. This is a simple query. So it's just an aggregation query. So we're going to get the customer ID and the sum of the amount from the orders table, grouping by the customer ID. So the result would look like this. So we have one row for each customer that shows the customer ID and then the sum of the amounts, across all the orders of that customer, which we have given the alias total amount. Again, very simple query. I think most of us can understand what this is doing. Okay, now suppose that I want to take it a step further and I want to get the maximum total amount paid by any customer, right? So looking at the results of that previous query, we can see that the maximum total amount paid by any customer is the $220, which was paid by customer number 3. So how do we write a query to output that value, the 220? You can say that, okay, like if I have that previous query as a table, I could potentially just select the maximum of the total amount column, right? So let's just do that. We're going to select the maximum of total amount from, I want to select this from the output of that previous query. So I'm going to use that previous query in the from clause as if it was a table. I gave it like a name here, called it customer totals, referring to that subquery. So basically I am using that query as if it was like a virtual table, and I'm doing further operations on top of that. I could not have done that on the original data directly. So if we run this new query that we have here, we will get the 220 value as we predicted. So that query that I put here in the from clause, this is what we call a subquery. Subquery is basically a query, a select statement, which I'm going to use within a larger query. In this particular case, I use the subquery in the from clause of the larger query. And when we put something in the from clause traditionally has tables, right? Like you select from table A, from customers, from orders, whatever it is. Usually the from clause has tables. So here when we put a subquery in the from clause over a larger query, it's like we're treating that subquery as if it was a table. The results of that subquery are not written to disk, right? Like this table, can think of it as a virtual table or a temporary table that exists in memory. So when you execute the main query, it's just going to execute that subquery as part of that, keep the results in memory, and then do whatever further operations that are needed on top of that. It doesn't always have to happen this exact way. Like, it doesn't have to happen in 2 different stages. This might be just happening as part of the execution pipeline. And, it might be executing the subquery at the same time that it's also like, running other operations. But this is just kind of like, a logical or a conceptual idea of what happens. In a nutshell, yeah, we can use a subquery in this way. As I mentioned, we use it in the from clause, but we can also use it in other places in the main query. Like we could put it in the where clause, in the select clause, in many different areas. So let's see some examples of that. Here is another example. I want to get all the orders that have an amount greater than the average order amount. Might be a little bit hard to understand, but let's try to kind of like decompose the question. So we want to get what's the average order amount, and then we want to get all the orders that have an amount higher than that value. So as we're thinking through it, you can see it's almost like there are two steps, right? First step is get the average order amount, and then second step is find the orders that have an amount greater than that average. So let's start with the first step, get the average order amount. That's a simple query. We're just going to average the amounts of all the orders, select average of amount from orders, and I gave it an alias, average amount. So in this case, we have this result, 97 point something. So this is the average of all the amounts of all the orders that we have. Okay, let's keep that number to the side because we might refer to it. So, okay, now we have done the first step. The second step is what we actually are looking for are all the orders that have amounts greater than that average, greater than that, the 97 point something value. How do we get that? Simple. Usually you would say, okay, just select from the orders table where amount is greater than this 97. But we don't want to put it, hard-coded in the query, so we're going to put the subquery that computed that value for us. So here we're going to say where amount is greater than that, that first query that we used to get the average. So basically we use that as a subquery in a larger query. And in this case, it's part of a filter in the where clause rather than in the from clause. So again, this is another way to use subqueries, and we get the result that looks like this. So we get all the orders that have an amount greater than 97, which are these three orders. Let's look at another example. Now we want to get all the customers who do not have any orders greater than $100. Can we get that directly from the original data? Someone might say, yeah, just select from the orders table, all the customers where amount is less than 100, right? But that would not work because let's look, for example, at customer ID 1. If we select where amount is less than 100, then customer ID 1 will be part of the result because customer ID 1 has an order that's less than 100, which is the first order 101. But that customer also has another order with $150. So that customer should not be part of the result. So we need to think about it a little bit differently. So to get what we're looking for, let's first get the customers who do have an order greater than 100. So first step, let's select customer ID from orders where amount is greater than 100. This will give us all the customers that do have, this kind of orders. So this will give us customers 1, 3, and 4. All three of them have orders that are greater than $100. The next step would be to get all the customers who are not part of this group. So anyone who is not in this group, it means that they do not have any orders greater than 100. So what we want to do now is to select the customer ID and customer name where customer ID is not in that group. So not in, we've seen that before. I've posted a different video before about join operations, and we talked about semi-join and anti-join. And in those kind of joins, we use in and not in, or exist and not exist. So that's a very common way of using subqueries. So in this particular case, we're getting all the customers who are not in that subquery, which will return only customer to Bob. So Bob is the only one that does not have any orders greater than 100. So in all the examples that we've seen so far, we've seen only one level of subqueries. So we've seen a subquery inside a main query. In general, there can be multiple levels. We call this nesting, right? Like, we have here a nested subquery inside the main query. Here we only have one level of nesting. You can have 2 or 3 or 4 levels of nesting. So in a subquery, you might have another subquery nested inside that, and then another one nested inside that, and so on. So let's see an example of that. The next question, or the next query that we want to write, is finding customers whose total amount is greater than the average total amount across customers. What does that mean? We've seen in one of the earlier examples how to get the total amount for every customer, right? So we just sum up all the orders for that customer, and this will be the total for that customer. Now, assuming that we have these totals, we want to get the average across these totals and then find the customers whose total is greater than that average. So again, there are multiple steps here that we have to do. Let's start with the first step, which we have already done before. First, find the customer totals. So each customer and the total for that customer. That's easy. So again, get the customer ID and the sum of the amount and group by the customer ID. This is what we will get. Again, we've seen this before. So let's keep this result on the side. Let's call it customer totals, right? Now, the second step is getting the average among these totals. So to do that, again, assuming that we have that result from the first query, we can just write a query like this that uses that first query as a subquery, right? And just computes the average of these total amounts. So the average of these four values will give us 170. So the average, across all the customers is 170. Again, let's keep that on the side. Now, given those two pieces of information, I have for each customer, I have the total amount, and I also have the average across these amounts. What we want the customers whose total amount is greater than that average, the 170 value. So if we want to write that, the query should look something like this. Basically, select customer ID and total amount from that first group, the customer totals that we have, where the total amount is greater than the average that we computed. Okay, so the things that I put here in yellow are not real, variables. These are kind of like a placeholder for something. Now we have to replace those with the actual query that computes each of those. So customer totals is basically the first subquery, getting the customer ID and the total amount for every customer. So we can replace that with what we have here, and it will look like this. So that's a subquery. And then to get the customer average, this is the second query that we got in the second step. So again, we can replace that with that query, which will look like this. So now we have the full query, and if we run this query, we will get this output. So we have those three customers, their total amounts. As we can see, each of them has a total that's greater than the 170 average that we computed earlier. So for this example, we can also see that we have multiple levels of nesting. We have, first of all, in the from clause of the main query, we have a subquery, and then in the where clause, we have another subquery which has an even further nested subquery as well. So we have two levels of nesting deep here. How easy is it to understand this query? Because we've been writing it together and we kind of like walked through the thought process, we can understand what's happening here. But give it a couple of weeks, and if you go back and look at this, it's going to be much harder to understand. Let alone if you're not the one who wrote this query. If you just look at this query and try to understand it, it will take some mental gymnastics to be able to understand. Also, if you look at queries that are in larger systems, usually like generated by business intelligence tools and whatnot, usually these queries are kind of like composed. So they would create a subquery and then wrap it within a query and then take all that and use it as a subquery in a larger query. So you might see, 15 or 20 levels of nesting. The more nesting you have, the harder it is to understand the query. That's a fact. Another thing to notice here in this particular query is that we also have some repetition here. So the parts that I marked with the yellow rectangles are exactly the same. This is basically the query that computes the totals, right? Like we used it once to get the average, and then we used it again to do the comparison at the end. So we have a repeated part, and if your database system is not smart enough, this means that this part is going to be executed twice to get the same result. Again, this is obviously like not great for the query performance. So when you have repeated subqueries or when you have complex subqueries that are hard to understand, it might be actually better to use the second thing that we want to talk about today, which is common table expressions. Common table expressions, also known as CTEs for short, also known as with clause, there are multiple names for that, can be used to achieve the same purpose that we wanted to achieve here, but in a slightly different way. A common table expression, or a CTE, is basically, again, it's a query, just like the subqueries that we have, that we give a name. So we assign a name to every CTE, and then we define those CTEs usually outside of the main query or just before or in the beginning of the main query. And then we can refer to them only in the from clause usually, just like we refer to a table. We can define multiple CTEs. We will see examples to illustrate that. But the way that we define them is using something that we call the with keyword, which we have not seen so far. That's why they're usually called the with clause. So let's see that is in an example. Here is one of the queries that we have already seen, getting the maximum total amount paid by any customer. And this is how we did it using a subquery. This was, I think, the first example that we talked about today. Now, let's see how we can do the same thing using a CTE. So again, like I said, we usually define the CTE using the with keyword before the actual main query. So we would put with, give it a name, and then put the body of the query. So here we chose the name customer totals, and then we added the select statement that represents that CTE. If we take out that subquery or CTE definition and run it on its own, we get this result that we have seen before. So I'll just keep it here for reference. Again, we're going to treat that as if it was a table. Now the main query becomes much simpler. The main query just becomes selecting maximum of total amount from the customer totals, which is the CTE that we have here. So as you can see, we're referring to customer totals like as if it was a table. Of course, again, like I said before, we're not going to write the results of the CTE to disk. This is something that just runs through the query execution. It's treated as, you can think of it as a virtual table or an in-memory table. And in this case, it's going to do the max operation on the results of that virtual table to get the result, which is 220. One thing to note is that we can define multiple CTEs in the same query. So here we have just one CTE, but you can have more than one. And then you can refer to all of them just like you refer to regular tables as well. When you define multiple CTEs, you don't put with clause with every one of them. You just put it once and then you separate with commas, as we're going to see in the next example. Another thing to note is that when you define multiple CTEs, each of them can also refer to other CTEs, the ones before it. Cannot refer to the ones after it in the definition. So the order of defining the CTEs actually makes a difference. And a single CTE can be reused multiple times. Again, we'll see what that looks like. Okay, here is the complex query that we have seen with subqueries, the one that had multiple levels of nesting, getting the customers whose total amount is greater than the average total amount. Again, this is what it looked like before. Remember that we've noted that we had some repetition. We had this repeated subquery. So we're going to use CTEs for that one. How do we do that? Like we said, we're going to define it in the with clause. So we're going to say with, let's call it customer totals, as that select statement. Now that we've defined it, we don't need to put the subqueries as we have them before. We just need to replace each of these subqueries with referring to the CTE. So for the first subquery, we're going to remove it and replace that with customer totals. And then the same thing for the second subquery, we're just going to refer to customer totals instead. So as you can see, we've already removed some of the complexity, we've removed the repetition. Now the definition is only done once. We can even also do that for the second subquery, even though it's only used once, but why not? So the second subquery that we have here, we can also pull that up as a CTE. So as you can see here, it's within the same with clause. We said with customer totals as something, comma, average total amount, which is the name of the second CTE, as something. So now we can remove that subquery and just refer to the average total amount that we defined above. So the whole thing will look like this. Couple things to note here. The customer totals CTE, which is the first one that we defined, is used multiple times. It's used in the second CTE, and it's also used in the main query below. And as you can see, like the second CTE is referring to the first one. So I cannot, reverse the order of defining these two. It has to be in this particular order because the second one is referring to the first one. If none of them is referring to the other, then you can put it in whatever order you like because it doesn't matter. But if there is some dependency, then each one has to refer to the ones before it. Only it cannot refer to anything after it. And then the main query at the end can refer, of course, to all of them. Okay, this is the same query using subqueries and using CTEs. So basically both versions of that same query that we have written so far. Between these two, which one do you think is easier to read? I would argue it's the second one using the CTEs because you have all the definition one after the other. You don't have a lot of nesting. Of course, you can use also like CTEs and subqueries together. It doesn't have to be only one or the other. Like at some some of the intermediate stages of the previous example, we had one CTE and we had a subquery, so this is also possible. But in this particular example, you can see that when we use CTEs, it's actually simpler and easier to read. It also kind of follows the logical way we were thinking about the query, like almost the same steps that we had. First, compute the totals, then get the average, then compare the average to the total. So you can see the CTE definitions kind of follows that order. So if you're going to, let's say, try to debug a query that looks like this, I think it would be easier to read, but it could be different for different people. Some people might find the first one easier to read. That's a matter of opinion. The other thing to note is that for performance purposes, the more that you have, let's say, if a CTE is referenced multiple times, right? Most systems will only execute it once, and then it will reuse the outputs of that CTE instead of executing the same thing over and over. Like when we had subqueries, the subquery maybe, if it's repeated, it might be executed multiple times. In some cases, a system might be smart enough to detect that the repetition is actually something that's repeated, and it will maybe pull it out and execute it once and then share or reuse the results. But in most cases, this does not happen. So for CTEs, you can actually save a little bit on performance. If you have a CTE or a subquery that's called multiple times, then you can use a CTE for that. In general, though, I would say in most cases, especially if a CTE is used only once, then the performance is not that different if you define it as a CTE versus as a subquery. Of course, it depends on the query. It depends on the complexity of the CTE or the subquery. It depends on the database system. Depends on what kind of optimizations it can do. The smarter the database system and the optimizer are, the less of a difference is between CTEs and subqueries. But I would say even if you have the same performance or very similar performance, I think the readability and the understanding of the query can be a factor. And if a query is too complex to write as a subquery, I think using CTEs would be better in that case. CTEs are not always, the way to go. Sometimes subqueries are actually better than CTEs, especially if you're using, again, like if you have a query that has in or not in or exists or not exists. In those cases, subquery is usually better because there are also usually some optimizations that happen in this case. For example, if you're using exists and as execution is happening, the minute it finds something returning from that query, it can usually like short circuit and not continue execution of that because it only wants to know if it returns something or not. So as soon as it does return something, it might stop, again depending on how smart the execution engine is. So there are many optimizations like that make actually subqueries useful in some cases. Also, there are things that I have not touched upon in this video so far. There are like some more advanced features of subqueries, like correlated subqueries, which they can refer to something coming from the main query. CTEs do not support that. So in some situations, you might be forced to use subquery if you have something like a correlation. On the other hand, CTEs also have some advanced features that they support. CTEs can be recursive in the sense that a CTE can refer to itself. Again, this is not a common scenario, so I do not put it in this video, but just wanted to point out that this is something that you can do with CTEs. Feel free to look up how to do that if you're curious. But yeah, there are things that you can do with either of them that you cannot do with the other. So in some cases, you might be forced to use one or the other. But if you are not forced to use any of these features, then it's up to you, up to the database system to decide which one of these would be more useful in your case. Do not follow people who are kind of, religiously with or against one of them. Some people say like always use a CTE, never use a subquery. Some people say the opposite. I would say you can evaluate the situation and figure out which one of them is more useful and makes more sense in your case. I hope this video was useful. I hope it cleared up some of the confusion between subqueries and CTEs. As usual, if you have any questions or comments, please add them to the video and I will try to answer or address them as soon as possible. If you found this video useful, please hit the like button. Please subscribe to the channel if you haven't already. And with that, thank you so much for watching and I will see you in the next video.